when it comes to the age question of the universe, many folk are interested in what the uncertainties are, or quite how you work out what the age of the universe is. How do we know that the universe is 13.7 billion years old, for example? Particularly as our perception of time is much more limited than that. And within cosmology, there's been a number of different ways of working this out. For example, if you know how big the universe is, and you know how quickly it's expanding, you know both of those fairly well, within a few orders of magnitude. But remember, we're talking about very big numbers here. Once you know that, you can work out when the whole thing was together. And that gives you, at a very crude example, a sense that the universe is billions of years old. You might debate just how many billions of years old, but that gives you a sense of that. Second way then to tie down a little more the age of the universe has been to look at the way that the chemical elements have developed within the universe. This was an area that I worked in specifically. The fact that atoms of carbon and oxygen and nitrogen, which now make up my body, were once cooked in the death throes of a previous generation of stars. And by looking at the distribution and the amount of different chemical elements, this gives you a fairly good handle on just how long the stars have been cooking the elements in order to get to where we are today. And again, we're talking billions of years. More recently, the Wilkinson Microwave Anisotropy Probe, which is a particular satellite that has been orbiting the Earth and looking at the universe. It's been looking at a particular form of radiation, the microwave background radiation. And if you look at the way that that light is polarized, or the way that it fluctuates in temperature, through a little complex mathematics, you come to an age of the universe of 13.7 billion years. Now, these are indirect ways of looking at the universe in the sense that all of them have within them certain assumptions. Assumptions like that the laws of physics are constant in different places over different times. Assumptions that the speed of light is constant. Anyone can question the individual assumptions involved in them, and some have. But once you begin to put these arguments together, and they all point towards the same length of time that the universe has been in existence, you become fairly confident that not that we've tied down the question absolutely, but that we've got a fairly good handle that the universe is billions of years old rather than simply thousands of years old.